Hola gente, ¿qué tal? Bienvenidos a una nueva edición de Meetup de Net-Baires. En esta oportunidad tenemos un invitado internacional. Tenemos desde Europa a Matt, que nos va a estar contando de una herramienta open source para automatización justamente de integración continua y deployments también continuos. Así que, bueno, esa es la idea. Primera experiencia haciendo una charla en inglés en este Meetup, así que vamos a probar cómo resulta. Cualquier pregunta que tengan, si quieren la dejan en el chat, nosotros la pueden hacer en español, digo, nosotros se la vamos a traducir al inglés, o pueden hacerla en inglés directamente, o pueden agarrar también sus micrófonos y interactuar como hacen habitualmente, ¿sí? Porque como estamos experimentando esta nueva versión, por ahí si se sienten tímidos o no saben expresar sus preguntas en inglés, las pueden dejar en español y nosotros las vamos a ir traduciendo. No sé, Germán, si querés agregar algo más.
No, que tenemos la charla y después tenemos una en español. Aviso por las dudas, después vamos a hablar de algo en español.
Ok. Sí. Después tenemos, justamente para no dejar todo en inglés, pusimos una de Germán en español para tener una oportunidad. Yeah. You are a presenter now, Matt. So welcome, Matt, to the Buenos Aires or Net-Baires meetup. We are very happy to have you here as a speaker for the first time. Be our guest.
See something.
Yeah. Okay, you can start whenever you want. No problem.
Okay, but you see my slides now, right?
Yeah.
Okay, that's good. Took me 2 attempts or so. Okay, so thanks for the introduction and welcome from my side too. I'm Matt. At my day job, I work at JetBrains, most things about Rider and ReSharper. If you happen to know about that already. But today I will talk about the project that I built mostly single-handedly, which is called NUKE, and I will tell a couple of things about that. Also, if you're interested, this is my Twitter handle, and this is for the project. And first, what I want to tell you today, and 45 minutes is actually pretty rough time schedule for that, so I will. At times I will probably rush through a bit, but what I want to tell you today is a tool that makes it pretty easy for you to build automation pipelines, no matter if CI or CD, and skip very serious pain points that I had in my past. That's why I came up with that. But also, I mean, there are several companies and other users that use it already, and I would kind of put that also into my pitch here. So some of our users are Octopus Deploy and Verticommerce. Both companies also sponsor the project. And also, if you happen to know about Avalonia, ASP.NET Boilerplate, Hot Chocolate, Fluent Assertions, those open source projects also rely on NUKE for their build automation. But before we dive deeper into the topic, for those that haven't heard anything about build automation before, I kind of like to use this picture that is from Gradle, because it depicts the whole software development cycle where we want to apply build automation quite well. It's usually something that can be simple, and some of you probably already use YAML pipelines for that. But it gets really, really complex over time. So it grows organically, and in most cases, it ends up pretty complex. And with build automation, we can implement steps like cleaning your solution, packaging everything, compiling everything, deploying it to NuGet as NuGet packages or as a website, or spin up Azure services and all that stuff we can do with build automation. And the whole idea behind that is that we eliminate the chance of human error. Because I still remember at one of my first companies where I worked, I was still as a student, and our boss was responsible to deploy the application. It was only him who could do that. and quite often things went wrong. But one question still is the elephant in the room, so to say, is most people immediately always say, but we have CI servers, so why not use something like YAML and all that stuff? Yeah, I mean, I said for simple things it works, but well, I would still, even for the simple things, I would actually recommend using NUKE. But the question is, why should I use that instead of CI servers? Because they have editors for that, which make it pretty or more simple and reliable, and wizards and all that stuff. But the reality here is, first of all, if you change something with your YAML configuration, then you end up in such situations where you have to commit a lot and just to see if everything works. And under certain circumstances, this also blocks other colleagues of yours from doing actual work or from getting their changes into the deployment pipeline, because, well, resources, they have a limit, right? And of course, this cannot be missed. For YAML, it's pretty easy to find all the different comments about it, how awful it can be. In some situations, it's also great, but for build pipelines, it really is a pain. And I'm sure you have seen some of those already. And that is the reason why, or some of the reasons why I think using a build system is a good idea. And about this whole YAML disaster, I also wrote a blog post, which is called Overcoming YAML Hell in Build Pipelines. And yeah, if you're interested, you can actually check it out afterwards. But now I will dive into some of the ingredients of NUKE. And if I'm not mistaken, I will have 11 points. And I start with the fact that NUKE works as a build automation system. And by the way, I sometimes might also use build system just as a synonym for that. It's a bit more different than a simple build system, because MS Build is also a build system, but just for you to note. So NUKE uses a console application for the implementation of your build, and that we can see here, for example. So this is just a demo project, of course, but this already has NUKE set up inside the solution. And we can see here it's a simple C# project. If you would go there, you would actually see it's a console application. And every console application, they have a static in main method. In this case, it only delegates to NUKE as a framework to actually execute your build. And two things we see here is, let's first put our attention here. We have two targets. Targets represent build steps in a pipeline. Yeah, so clean would be a target, compile would be a target, pack would be a target. In this case, I will just stick with hello world. And we also see that the world target actually depends on hello. And this is a common practice. You will also see this in any other build system, actually. Also in MS Build, I'm sure most saw some MS Build custom targets at some point in their career. And yeah, this is how you write this stuff in NUKE. And most importantly here is targets are actual symbols. So in this, they are properties with an expression-bodied implementation returning a delegate. So that's just as far as the syntax here goes. But it doesn't really matter, because everything that you want to implement for that target, you put into this executes block, basically. And up here in the, I didn't mention that, but here in the executes method that delegates, you can also define the default target that should be executed if from outside you call the build and you don't pass any other target that you want to run. Okay, and more importantly, that I forgot, you can put breakpoints anywhere you want. That is really something that isn't possible. Even that's quite difficult with MS Build, as far as I know. That is almost impossible or probably actually impossible with YAML. So you can't inspect variables or stuff like that. With NUKE, it's a console application. Everyone has worked with console applications, so you can do that. The second ingredient here for NUKE is the global tool, and that is can be installed with that command. I guess most of you are probably aware of the .NET global tool, so this is how you can install it, and that allows you to call NUKE from the command line. What we have above here is the help output actually. And down here you also see, and that's something that NUKE that you can where you can configure your terminal to do that. You can actually use completion. So for instance, we see there's a compile target that's here. There's a skip parameter which receives other targets, and you have completion for everything that's that is possible to complete. Okay, if you have any questions, I currently only see a language I cannot understand. But if you have any questions, feel free to post them. I will keep an eye on that. Okay, the other thing I will just briefly mention it. If you want to set up a repository with NUKE, then that's what you do. NUKE : setup, and the wizard will guide you through a couple of questions, like how do you want your project to be named, where should it be located, which version should be used, and should it be added to the solution as well. Because that's really you saw that in the initial in the initial screenshot, but this is really something quite helpful, that you have your build project just next beside your other projects in the solution. It's really accessible. And all that stuff also allows you to navigate there, right? Very easily with Rider or Visual Studio, whatever navigation you use, this allows that. Okay, and apply changes after the setup. Just to name it quickly, there will be a NUKE folder added. So currently it says root directory. Currently it says still marker file, but meanwhile it's actually a directory. The C# project for the console application, this one we have seen, this is the default build. Also 2 files for execution in your CI environment, whether it's a Windows environment or a Linux-based environment. And this is also to make formatting a bit easier. So for normal editor config and for Resharper and Rider to read formatting changes or settings from. Okay, third ingredient is the target model. And for that to start with, I want to show you a typical dependency graph, how you often see it in build automation. We start here something with compile, for instance, and excuse me, but the arrows, I know usually they should point into the other direction, but at the time I took that I used a JavaScript framework for that. I didn't know how to point into the other direction. So, but we have the compile target. Unit tests requires the compile target, so depends on it. Same with integration tests, and this is like a collective target which triggers both unit tests and integration tests. Also, we have pack, which depends on compile. And if you would, just as an example, if you would trigger tests, the target tests, then first compile would be executed, then unit tests and integration tests, and then this collective target. But it's not always that simple. So not always we have these strong dependencies, which are also illustrated with just simple solid gray edges. But sometimes we also have this case, like for instance, compile and the clean target, and they don't necessarily depend on each other, but when they are executed together, then clean should happen before compile, right? Because when clean would happen after compile, it wouldn't do anything meaningful. Now the interesting part comes, and you can actually model that. But the interesting part comes when you have something like a publish target, which triggers all that stuff like compile, pack, and test. But it also, as soon as I invoke publish, now the clean target is required, and it will automatically be scheduled before the compile target. Last but not least, this is kind of more about semantics, but if you happen to have an announced target, let's say you publish a website or you publish your application and you want to put something out on Twitter, social media, anywhere, then usually you wouldn't want to call your build pipeline and say, I want to call announce. That sounds a bit weird. But in this case, you just call publish, and this yellow edge here reflects a trigger dependency. So trigger basically says whenever this is executed, it triggers the announce target. And in the end, you can still say, I want to execute publish, and basically everything gets executed. So for that, to model your dependencies and target definitions, and let's stick with the example of compile depends on restore. Restore we actually didn't happen in the last screenshot, but let's say there's a restore target before. You could, for one, you could say from the compile target, it depends on restore, but you can also say from the restore target, it is dependent for compile. So this is a matter of where you put that information, and this is really interesting because sometimes, especially to make targets more modular, it really does matter where you put that information. Because let's say, like with the oh, I will actually come to that example later, but let's continue for now. This ordering dependency, those can be modeled with before and after. And the publish, that's actually what I wanted to say. For publish, we could say it triggers announce, but from my point of view, a much better approach is to say announce is triggered by publish, because the publish target shouldn't know anything about the announce target. Also, what we can do is for certain targets, and let's say we have a cleanup target, we can define that it is assured after failure. So that means that even if there are errors before, this target is assured to be executed. The same is with if your targets can swallow exceptions more or less, then you can define them as proceed after failure. And there's also a way to write conditions. So under certain circumstances, you don't want to actually execute a certain targets, and you can define static conditions which are checked at the beginning of your immediately before the target would execute. Okay, and you can also skip behavior if one of the if one target is skipped, then you can define if the dependencies should be skipped or not. Okay, CLI Tool Support, and that is quite important because let's go back. That is quite important because build automation has historically is always dependent of integrating other tools like most importantly, .NET CLI for .NET developers, of course, but also Docker, the Azure CLI, let's say, or NSWAG, and everything you can think of. Yeah, NUKE comes with support for quite a lot. Meanwhile, I don't even have many requests anymore for other tools. So NPM is also supported, and Yarn is about to be merged. But what I want to show you here is a way how you interact with those tools. And one of them is .NET. More importantly, more specifically in this case, we will deal with the .NET build command. And as you see, we can actually this would be in a method body. What I'm showing here is we can actually use code completion and say .NET build. Okay. So now, and this I forgot, documentation is always included, and it's in most cases, it's the same documentation that you would find online for the different commands that are available. Okay, so now with this .NET build command, you might want to go ahead and say, okay, I want to set the project file. Okay, and you can do that. You say set project file solution, and it will set the project file to the solution for the invocation of .NET build. We could go further and say I want to enable no restore, and you also see there are a couple of other methods. This is basically for composability, as you will see later. But for now, let's just say enable no restore. So the --no -restore parameters passed, and also we could pass the verbosity. In this case, you can see it also filters down to, because in this case there's a specific set of arguments that you can pass, and NUKE actually knows about them, so you can say .NET verbosity. Okay, and like I said, for all of these methods, there's documentation around, so you actually see what this is doing. Now composition. And by the way, I call this whole stuff the Fluent API for tool invocations. Now let's move over to composition, because sometimes you want to manipulate your invocation based on some other outside conditions, let's say, and publish test results. In this case, it's just a bool value, and this whole thing basically says that when this is true, then let's also set the logger and set the results directory. Another way of composition is this whole thing where I'm actually publishing or using NuGet push for a bunch of NuGet packages. And this can be any number. This could be 10 NuGet packages. And whatever the amount of NuGet packages is, this command will exactly invoke that number of tool invocations for .NET as the number of NuGet packages is. So this single command would push all the 10 NuGet packages. And you can actually tell it about the degree of parallelism, and you can also say whether you want to complete on failure. Because let's say one run only pushes one package and the others fail. Now in the second run, of course, you just want to push the other 4, but you still wanted to attempt pushing the other 4 and not just fail after the first that succeeded already. And yeah, just to clarify, the first part here is actually that part that is common for all the invocations, while here set target path is different for each of the NuGet packages. And this is basically how the invocation would look like. You see 4 invocations for four different packages. And this is how it looked like a while back on my Bitrise server. Of course, you don't use this Fluent API in all cases. Like for Git, I wouldn't want to do that, of course. But you can still use string interpolation, which does the job perfectly in some cases. But I still hope that these two, the composition with that multiplies and the composition with conditions, kind of illustrates that this would be much more difficult with string interpolation, because you have a lot of string construction for the command that you finally want to invoke, right? So I wouldn't want to write constructions and build the whole command with normal in the normal way, like string concatenation. Okay, fifth thing is path handling. And the idea in NUKE is to always use absolute paths as opposed to relative paths, because relative paths have the how do you call it? Have the danger you might run into a situation where you have a relative path and you switch the current directory, the working directory, and somehow your invocation doesn't work anymore. So the idea is to pass absolute paths all the time. And the way how you do this is using division operator magic. But not only that, but also a a base property, which is called root directory, which holds the path to the directory where the marker directory is located. So it's more or less the base of your Git repository, if you happen to use Git. And from there, you can, in an agnostic way, you can construct absolute paths. So in this case, this would be handled differently on Windows and Linux, of course. Whatever they need, if it's a slash or a backslash, and this is the abstraction for that. And as you can see, you can quite easily construct different paths from there. You can also reuse something that you have defined beforehand, and this is really easy also to refactor and to avoid writing paths multiple times and then having to walk around and change them if you want to change them. This is really like I want to think about build automation, that you don't repeat yourself. But still, from certain directories, you can still create. You can also create relative paths if you happen to need them, and you can use relative path for the operating system you're currently using, or specifically for Unix and Windows. And this path handling also allows you to use globbing mechanisms. So, for instance, in this case, the property which accumulates all the markdown files. Or the markdown files from the root directory. It's just really simple. Okay, now the sixth ingredient is parameters and auto injection. And two things for that I want to kind of motivate that topic is, first of all, build automation often relies on the fact that you pass parameters from the outside, right? And more importantly, you want to pass parameters of very different kinds. You may want to pass arrays, you may want to pass Boolean values, strings, integers, and all that stuff. And also for auto injection, and they actually use the same concept to solve this issue. But for auto injection, what I also often see is, for instance, with Git version. Git version is a tool that allows you to construct a semantic version based on your commit log. And what I often see is that people have some kind of a setup target, which calculates this semantic version. But the setup target is basically a root target for everything inside your build. So that's something, both of these is something I wanted to solve. And the way I solved this is with attributes. So let's focus on parameters first. The only thing you do, and I already mentioned, there might be very different kinds of parameter types. So string, array of strings, a nullable bool, and all that stuff. And you just have a name. So they are all fields. And you put the parameter attribute on it, and now this would be the command line usage that you how you pass the parameter, and you just say --value hello. It would be inside that parameter. For bools, you can use just switches basically, but you could also pass false and true if you want. A local path, in this case, like I said, I always want absolute paths, but you can totally pass a local path, but it will automatically be constructed to an absolute path. Configuration is the same. This actually defines just two public properties, and which is release and debug. But now you can really you can quite easily resolve them from command line, and they're just there. The second part was about setup stuff, and these are some examples for that. So, for instance, the solution type holds a full, accessible, readable, and writable model of your solution. We will later look at that also. Git repository comes with a lot of information about the current Git repository, like origin, the current commit you're running on, the branch, and all that stuff. And Git version is the example that I put forward, and this actually also invokes Git version in the background before any of your targets starts. And down here you see the output for all those fields. I think it's self-explanatory what happened here. Also, because, like I said, passing parameters is a big thing. But often you also have some kind of default parameters. And my take on this is you don't want to necessarily put those into your code because it's configuration. The implementation I showed you is really just the implementation. This here is the configuration. And the default configuration happens in something that I call parameter file. In this case, the parameters JSON file. And this is just the default configuration for my build. You see, for instance, solution points to my solution file. I have also a couple of IDs here. But also if let's say for between the dev execution and developer execution and production execution, I want a different ID, then I could put those in here and just define it based on the profile I want to execute. So those two I would call profile. I'm still not sure, 100% sure about the naming, but I hope you get the idea. Parameters, what's really cool about them is that they allow you to write requirements for your tasks. And sorry, as an example, let's take the API key. The API key is something that is needed in the publish target, but let's say if it's not passed, then you don't want to wait until the publish target for the build to realize, okay, this is missing. So requirements are actually checked right at the beginning of every build execution, and they will fail the build immediately and not not to spend too much time on execution, which is basically worthless. Okay, solution model I want to make really short, I hope. This stuff we already had, but there's a special thing here, which is the generate projects property that you can set to true. And this allows you to use the solution object to have I would say a typed access to your solution model, because NUKE global tool and NUKE MS build tasks, those are actually projects that are defined in the solution file. And so whenever you happen to rename them or reorder them in your solution, this would actually be noticeable, because the symbol would no longer be resolvable. And I hope I mentioned this is all based on source generators. And also for projects, this stuff is integrated with the MS Build, MS or Microsoft Build NuGet packages. So for any project, you could retrieve target frameworks, runtime identifiers, or any other property that you can think of. And this way you could very easily generate something called publish configurations. So again, this is about the composition I also showed earlier. So this will call .NET publish for all the different combinations that are resulting from this call here. Again, very dynamic, because once I put another target framework into my global tool, for instance, the build will already know. You don't have to update your build. This one I will skip. The next one, and this is the real fun part, is CI support. And let's start with the simple thing. Of course, it will kind of try to help you to make your build a bit more structured, so you automatically have this collapsing if the build CI server supports that. This one is GitHub Actions. But the really fun part is the configuration generation. And let's say we will start with something when I want to execute my build on AppWare, let's say. This is the way how you can do it, because you just put an attribute onto your build class. You define the images for which it should run, and the invoked targets. And again, here this is also quite fancy, because we can use the name of operator again to have the build really solid and not become out of date, because let's say you rename the test target. Because if you rename the test target, this one here will also update automatically. And to generate that configuration, you just have to execute NUKE one time at least. You can pass -- help or something to it. But you have to execute it one time to let the generation actually be generated. And this is, for the AppWare case, this would be the AppWare YAML file. And yes, this still looks quite simple, let's say. I mean, I get it. But this is the simple case, right? Because I wanna put one more example forward. Let's say we have a pack target which produces NuGet packages. Then all we have to do is put this inside here, regenerate the configuration, and this is what AppWare then tells us. Artifacts get automatically published. We didn't have to do any YAML searching how this artifact publishing is done or anything. It just happens to work. And this produces is not specific to AppWare. I mean, it would also work on, so currently we support Azure pipelines, TeamCity, GitHub Actions actually, yeah, GitHub Actions too. I was just not too sure about the artifacts. And space automation from JetBrains, and what was the other one? Okay, I probably forgot, but a few. So the most important are there. Now one very interesting example is also something that I kind of still investigate is test execution. So if your solution happens to have a very long test execution, and my telemetry data says middle is something along the 20 minutes that people have, then this is something that you can use to reduce that amount of time. Because let's say we have a test target and just this is something I basically explained with the combine with. But the interesting part here is the partition and the way how we get the relevant projects. Because first of all, with the partition 2 here, with that call, I basically tell NUKE that on the CI server where it's supported, it should parallelize this test target onto 2 different agents. Okay, and the first call here is all test projects. The second call uses the partition base member to get the current chunk on whatever agent NUKE is currently running to get the relevant projects. Now, this is how it looks from my own project. I only have 2 test assemblies, and you also see one of them only has 1 test, but it's actually separated from each other. I have a better example where I used an artificial solution with around 17,000 tests. And in the first instance, you see here, this was running on 3 agents. It took roughly 30 minutes. Then I switched over to 10 agents. And this is really just a matter of changing the value here to 10 and to regenerate, of course. But now you see with 10, it's already at 5 minutes. This was a cold start, and with a hot start or warm start, it's even down to 3 minutes. And this is quite interesting because the distribution looks roughly like this, at least for the artificial project, where I had unit tests and system and integration tests, because they usually have a different amount of different duration how they run. But this is the naive, let's say, distribution, but you can actually do much better. And I started with TeamCity to retrieve the last execution times of tests, and that allowed to kind of optimize that distribution a bit. Of course, we can't get to an even distribution because this separation from each other works best on test project level. I mean, it makes no sense to build a test project on 2 different agents, most of all also because they might have different test setups, and then you would prepare the database twice and stuff like that. So there is a limit, but it gets much better. The 9th thing is IDE extensions, and as I already mentioned, NUKE is a simple console application, so you could just start it pretty much. But it can be much better, right? Okay, to this I will come in a minute, but first of all of the IDE extensions, they come with a snippet or live template that makes writing targets a bit easier because it's just the end target snippet, and that allows you to just write a target. Because I admit that last part here with the lambda arrows is a bit hard to write, so use the extensions to actually write a target. But now back to execution of targets. This is how it looks in VS Code. So above every target, you have a run and debug code lens item, and also from the command palette you can choose, for instance, and this is really helpful, to debug or run without dependencies. So usually what I've done before when I didn't have this was to actually delete dependencies and then invoke again, and then I had to add the dependency back again to it. Sometimes I even forgot adding back the dependency. So this will skip the dependencies and makes build authoring much easier, because you can just troubleshoot what you're writing quite nicely. This is how it looks in Visual Studio. So you can there are two buttons to attach, basically debug and to skip. It's not so nice, but the extension points for Visual Studio, that's the best I could come up with. And here you can just double click to execute a target. In Writer and ReSharper, it looks like this. It's integrated in the Alt-Enter menu. You also see in the gutter mark, there's an icon for a NUKE target, and you can just hit Alt-Enter, then enter again to execute the target, or arrow key to the right, and then debug or run debug without dependencies. This is also pretty cool because it will show up on how to say on the MacBook with the touch bar. Yeah, it was just funny. And one more thing, and this is really a thing that comes with being a console application. We can write analyzers and code inspections. For instance, here in this case, you see I'm passing an API key, which is clear text, and it tells me, hey, this is a clear text secret, at least it looks like. Maybe you want to make this a parameter and also mark it as a secret. So it really tells you about the dangerous things inside your build implementation. And you can quickly create parameters and all that. So this is really an opportunity, and I think there are a lot of more things that could come here. This was something I was experimenting with, to have a live diagram. I will actually just skip that, but it's funny to do so because once you change something, it automatically reflects in the diagram. Previous to last thing I want to mention is build sharing, because often build implementation is not just a thing for a single project. You want to use that in different repositories, right? And there are actually many ways how you can do many strategies how you can do build sharing. Some of the obvious ones are Git submodules and NuGet packages. Then there are also external files. There's the way that you publish your build as a global tool. And this is something I want to show you, interface default members. It's a feature of C#7 or 8, I forgot. But it looks roughly like this. Like you can put your target inside interfaces. And actually you could implement that here. I just kept it concise, just for the matter of to put it as an example. But we have this I publish NuGet, let's say, with a pack and publish target, and we have this announce target, which also implements an announce or the I announce interface, which defines an announce target. And this try triggered by, what it does is actually just to see if the concrete build that we have has an I publish NuGet implemented, and then it will be triggered from the publish target. And then we can also see we have a message, for instance, that the concrete build would need to implement. And if we inherit both of these interfaces, then what we get is something like this. We have a build which inherits both interfaces. We have to implement the message, of course, because this is what the interface requires us. The output directory also, I think this comes from this from that interface. And we actually inherited the pack, publish, and announce target. We don't need to implement that because it's done as interface default members. But we can still from here order a clean target, let's say, to put it before the restore, for instance. Here I build defines a restore target, let's say, and we can also say that clean is dependent for the publish. That's exactly like I shown initially with the example dependency model. And that's basically how you how you can do build sharing. You can still distribute them as NuGet packages, but this is quite powerful. This is also something that Octopus Deploy is currently playing with, because it removes all that repetition across different repositories in terms of build automation. It's, again, don't repeat yourself. The last thing, and also this is something I also currently just play around with, are notifications, because once we're already in C#, it's pretty easy to do all that fancy stuff and integrate it nicely through attributes, let's say. Because in this case, for notifications, I just put a Slack notification attribute onto my build, and this is what happens. So as soon as the build runs, you can see let's wait for it to restart, but you can see how the different targets are proceeding. Green, of course, is when it succeeded. Red is when it didn't succeed, when it failed. So let's start again. So you see restore, now compiling, now test failed. It says it even tells you about the exit code. You have all the links here which direct you to the web UI. You can see the commits that are relevant to that build, the exit code, duration, and even this is pretty cool too. While it's running, you also see an ETA when it should be finished. Okay, so takeaway. I think from my side, the biggest points about that is full IDE support. You don't need to become a YAML developer with a kind of a ruler attached to your screen. It provides a very fast feedback cycle because you can execute it locally. I think I didn't point that out too well, but you can execute all that locally. You don't need to push to CI server to see if your changes are working. Tool support is very nice. You can generate your CI configurations. And the build sharing, of course, I think there's great potential in that. And with that, I would close. I would be happy if you put a star on the GitHub repository or follow on Twitter. And if you have any questions, I'm still around. I'm not sure if we immediately switch to the next presentation. But anyways, if you have questions, you can also post them on Twitter. Okay, and thanks for your attention. So.
Okay, thanks, Matt. Very, very interesting talk. I haven't seen this tool before, and seems very, very cool. I don't know if there is some question. Let me ask in Spanish. No sé si tienen alguna pregunta. Si quieren dejar alguna pregunta, pueden usar el chat, o si se animan, pueden también usar el micrófono y preguntar. No sé, Germán, si le querés hacer alguna pregunta a vos mientras.
No, I'm thinking about, are there some important project that is using now this tool?
Sorry, I didn't get the question.
Some project. Are there some project that are using this tool?
Yeah, well, it was at the beginning. So it's Octopus Deploy. They use it intensively already. Verticommerce is another company, but both of them are also sponsoring. Avalonia, so the cross-platform UI framework, ASP.NET boilerplate, Hot Chocolate. The maintainer is actually a very good friend of mine, and we actually also met because of NUKE at a conference. And Fluent Assertions, I'm sure most will also know as a very great test assertion extension library for writing tests. So yeah, those projects most prominently, but there are a couple of more, of course. I have actually telemetry data when people are okay with that, and currently we have like 250 daily active repositories and around 100,000 builds per month.
Oh, okay, so good.
Excellent. I just put a star on your repository, so
thanks.
You have a new star. So, well, that's all. I think we have no more questions here in the chat. But thank you very much, Matt. It was very interesting, all the presentation, and of course the tool. I will use it. I will try it and let you know if I have any other questions on that.
That would be
well,
cool.
I hope I see you again, maybe in this meetup, or maybe in other event, maybe.
I have a couple more things to talk about. We can see if we can follow up with that. But also from me again, thanks for invitation. It's great. It was great being here. And thanks for hosting and all that. Many thanks.
Okay, thank you for your time.